Hello everyone. In this lecture today we will see second case for finding particular integral pi. In previous lecture we have seen first case for finding pi, and we know that these cases differ from one to other on the basis of nature of given function capital F of x. Okay, so if capital F of x it is equal to sine ax, trigonometric function sine ax, then or capital F of x equals to cos ax. For both functions, we are having the similar method. If the function is sine ax or the function is cos ax, means if we are having a trigonometric function, then it should be either sine ax or cos ax only. Then and then we will apply case number 2. Other than that, if we are having any other trigonometric function, then we cannot solve them by using case number 2. Okay, so here now formula for pi, it is equal to 1 upon f of t operating on capital F of x. Substitute here value of capital F of x. So by substituting value of capital F of x, suppose it as sine ax, it will become 1 upon f of d operating on the function sine ax. Okay. Now, for finding its pi, and function is trigonometric, sine or cos. In this case, we have to express f of d in terms of d square. In case number 2, we have to express f of d. F of d, it is nothing but the operator present in the denominator of equation number 1. जो भी f of d का value यहाँ पे present रहेगा. We have to express f of d in terms of d square. If by default d square is present, then no problem at all. And if the term of d square is not present, then we have to convert this operator in the form of d square by adjusting some terms. Okay. After getting the term of d square, then we have to replace d square by minus of a square. After getting the term of d square, then we have to replace here d square by minus of a square. So in first case, if the function is exponential, then we replace d by a. And in second case, the function is trigonometric, then we have to replace d square by minus of a square. So by replacing d square by minus of a square, we can get the required pi. And condition, same condition is applicable here. Denominator should not become 0. Agar denominator 0 आता है, तो again same method we have to apply. We have to multiply by variable x and take derivative of operator f of t. So same thing is applicable in all cases. Then the same process is to be applied if capital F of x equal to cos ax. So as I said you earlier, कि function sin रहे या cos रहे, दोनों में method same है. ठीक है? So in previous lecture we have seen case number 1. In case number 1, if capital F of x it is equal to exponential function a to the power ax, then in that case we have to replace d by a. And in case number 2, if the function capital F of x it is equal to sine ax or cos ax, then we have to replace d square by minus of a square. And that's why d square is necessary. It should be present in the operator. और अगर d square नहीं रहता है, तो पहले हमें d square के फॉर्मेट में ऑपरेटर को कन्वर्ट करना है, and after that we have to replace it. Okay. So moving to the problem. Before moving to the problem, there is some note regarding this case number 2. So for applying case number 2, we have to always ensure that power of sine function or cosine function, sine ax cos ax, जो हमने यहाँ पे standard function लिखा है, power of sine function or cosine function should be 1 only. Means it should always be in linear power. And they should not be in multiplication with any other function. They should not be in multiplication with any other function. We need simple, single and separate function. Single and separate function. Sine function should be separate. Cos function should be separate. It should be free from multiplication, any type of multiplication with other functions. Okay. So first requirement is that the power should be 1. And second requirement is that there should not be multiplication of 2 functions. So then and then only we can apply case number 2. Now moving to the problem. we have to solve d to the power 4 minus m to the power 4 operating on y equal to sine mx. So given differential equation, d to the power 4 minus m to the power 4 operating on y equal to sine mx. Now its complete solution is given by cs equal to cf plus pi. So first part we will calculate cf, complementary function. So for getting cf we need auxiliary equation. So its auxiliary equation is given by f of d equal to 0, and here value of f of d, it is d to the power 4 minus m to the power 4. It is the operator. So d to the power 4 minus m to the power 4 equal to d0. Now here we are having 4-degree equation. Highest degree, it is 4. So 4-degree equation है, it means that इसके total 4 values आने चाहिए, 4 roots should आने चाहिए. So अभी 4-degree equation है, and again it contain a constant m, so we cannot calculate it by using calc. इसे हमें manually solve करना है. तो डिग्री 4 का इक्वेशन हमें solve करना है, मैनुअली हम सोल्व कर रहे हैं, और टोटल 4 रूट्स आने चाहिए. सो वी कैन राइट दिस d to the power 4 and m to the power 4 as d square bracket square and m square bracket square. d to the power 4 है, we can write it as d square bracket square. m to the power 4 है, we can write it as m square bracket square. And now it is in the form of a square minus b square. Now this equation, it is in the form of a square minus b square equal to 0. And a square minus b square means we can write it as a minus b into a plus b. Okay? So a means d square and b means m square. So it will become d square minus m square and d square plus m square. So I am writing it here. Therefore, d square minus m square into d square plus m square equals to 0. And now it means that either first bracket equal to 0 or second bracket equal to 0. So d square minus m square equal to 0 and d square plus m square equal to 0. From first equation, we can get d square equal to m square. Minus m square को right side पर transfer कर दिए, d square will be equal to m square. And from second bracket, it will be d square equal to minus m square. Now, again, come back to the first equation. First equation is d square equal to m square means d equal to plus minus root of m square. And second equation, d square equal to minus m square means d equal to plus minus root of minus m square. Okay. Now, in first equation, root of m square, it will be just m. So d equal to plus minus m. But in second bracket, we are having square root of minus m square. तो ये माइनस को हम रूट के बाहर नहीं ले सकते, बट वी कैन टेक दिस m स्क्वायर आउटसाइड ऑफ दिस रूट. तो m स्क्वायर को अगर बाहर लिया तो इट विल बिकम d इक्वल टू प्लस माइनस m इनटू रिमेनिंग टर्म इज स्क्वायर रूट ऑफ माइनस 1. एंड वी नो दैट वैल्यू ऑफ स्क्वायर रूट ऑफ माइनस 1, it is equal to I. So d equal to plus minus m means d equal to m comma minus m. These are the two roots from first equation, and d equal to plus minus mi. These are the two roots from second equation, since I equals to square root of minus 1. So total 4 roots हमें चाहिए था. We are solving an equation having degree 4. So उसके total 4 roots आने चाहिए से. So we got 4 roots here. First root plus m, then minus m, and then plus minus mi. Now plus minus mi, it contain imaginary term, so it's a complex pair. So let plus minus mi, it is equal to 0 plus minus mi, because we need real part and we need imaginary part. तो real part यहाँ पे present नहीं था, that's why हमने इसे 0 लिख दिया. तो 0 plus minus mi, and we can equate it with alpha plus minus I beta. So therefore roots contain a complex pair. Total 4 roots are there, and out of 4 roots there is a complex pair. So therefore CF will become CF equal to, first we will write formula for complex pair, and after that we will write formula for remaining real roots. First 2 roots are real, plus m and minus m. These two values are real, though it is in the form of a pair. Plus minus m के format में ये value आई थी, but it do not contain imaginary term I. So we cannot compare it with alpha plus minus I beta. It is completely real. That's why हमने इसे separate कर दिया. First value plus m, second value minus m. But next जो root आया है, it is plus minus mi, तो it's a complex pair. तो पहले complex pair के लिए हमें लिखना है. So for complex pair, formula for CF, it is equal to C1 e to the power alpha x in bracket C1 cos beta x plus C2 sin beta x. e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. It is the formula for CF if we are having a complex pair as a root. तो दो कांस्टेंट यहाँ पे आ गया c1 c2 means this is sufficient for two roots. तो ये जो कॉम्प्लेक्स पेयर था ये दो रूट के लिए हमारा फॉर्मूला आ गया. Now remaining two roots are real. This one remaining two roots m and minus m, these are real. तो रियल रूट के लिए पहले m के लिए नेक्स्ट टर्म हमें ऐड करना है. इट विल बी c3 into e to the power m3x and last root it is minus m. So for that एक और टर्म ऐड करना है plus c4 into e to the power minus mx. So again I am repeating the total number of constants in this equation are 4, c1 c2 c3 c4. So number of constants should be same as number of roots. जितने roots आएंगे उतने constant compulsory है. तो 4 roots थे 4 constant आ गए. It means that the CF it is correct. Now we have to substitute here values of alpha and beta. So let's say what is alpha and what is beta. So alpha is the real part. It is 0 here. And beta it is the imaginary part. Imaginary part means coefficient of I. So it is m. So value of alpha is 0 and value of beta is m. So substituting these values, alpha equal to 0 अगर put किया तो exponential term it will become e to the power 0. Beta equal to m put करना है, so it will become cos mx, it will become sin mx. So CF equal to e to the power 0x in bracket c1 cos mx plus c2 sin mx and plus c3 e to the power mx, it is as it is, and plus c4 e to the power minus mx, again it is as it is. Now we know that e to the power 0x it is 1, so we can remove it from here. Remaining equation is CF equal to c1 cos mx plus c2 sin mx and plus c3 e to the power mx plus c4 e to the power minus mx. So this is the simplified CF for the given differential equation. Now second part of the problem, we have to find PI. And formula for PI, it is PI equals to 1 upon f of d operating on capital F of x. So here we need value of operator f of d and value of function capital F of x, which is present on the right hand side of given differential equation. So let's check the values one by one. Okay, so value of f of d, operator is here d to the power 4 minus m to the power 4, and value of capital F of x, function present on right hand side of the equation, it is sin mx. So substituting these values in the formula of PI. So it will become 1 upon d to the power 4 minus m to the power 4. You have value of f of d and sin mx, you have value of capital F of x. Now we know that if you are calculating PI, then it depends on nature of given function. So here function it is sin mx. Sin mx, power of sin function is 1 here, and it is free from any type of multiplication with other functions. It means that we can apply here case number 2. Case number 2 जो हमने देखा था sin और cos के लिए, वो हम यहाँ पे apply कर सकते हैं. But if you want to apply case number 2, then by using case 2, we have to replace d square by minus of a square. d square की जगह पे हमें minus a square replace करना है. So अभी यहाँ पे minus a square, d square को minus a square से replace करना है. It means that we need a term of d square in the operator. But operator के अंदर d square का term तो यहाँ पे है नहीं. We are having here d to the power 4. So what we will do? We will write it in the form of d square as 1 upon d square whole square. d to the power 4 जो था, इसको फिर से d square के फॉर्मेट में लिख दिया. We can write it as d square whole square minus m to the power 4 as it is. And why we have written it in the form of d square? Because by using case number 2, we have to replace d square by minus of a square. Okay. Now we got here the term of d square. We got here the term of d square. So now by using case number 2, we have to replace d square by minus of a square. By using case number 2, we have to replace d square by minus of a square. So what is a here? A, it is the coefficient of x in the angle of that sine function. A, it is the coefficient of x in the angle of that sine function. So it will become d square equal to minus of m square. So applying this value, we will get here PI equals to 1 upon minus m square. So ये आ गया d square की जगह पे minus m square, bracket square as it is, minus m to the power 4 as it is. Now this minus m square and again it's a square. It will become plus m to the power 4. Next term is minus m to the power 4. It means that denominator will become here 0. So therefore, pi it is equal to, on right hand side, we are getting here denominator as 0 because m to the power 4 minus m to the power 4, it will become 0. So in right hand side, denominator is going to be 0. That's why we have to multiply the right hand side by variable x and take the derivative of operator. So pi it will become, पहले तो x से multiply करना है, and after that we have to take the derivative of operator. So in place of f of d, now we have written it as f dash of d, and function sin mx it is as it is. Function में कुछ change करना नहीं. Now here we need value of f dash of d. So in this problem, value of f of d it is d to the power 4 minus m to the power 4. So take its derivative, f dash of d, it will become derivative of d to the power 4, it is 4d cube, minus m to the power 4, it's constant, so its derivative will be 0. So substituting this value in denominator here, we will get pi equals to x into 1 upon 4d cube. ये हो गया value of f dash of d. Function sin mx, it is completely as it is. Now 1 upon 4d cube operating on sin mx. So जब तक d remove नहीं होगा तब तक हमें continuously solve करना है. So again, function is sin mx means we have to apply case number 2. And if you want to apply case number 2, then we have to replace d square by minus of a square. So फिर से ये d cube को हमें d square के format में convert करना होगा. Again, converting in the form of d square. pi, it will become x into 1 upon 4d square into d. We are having 4d cube. So I have written it as 4d square into d, and function it is as it is. Okay. And now we got the term of d square in the operator. So apply case number 2 and replace d square by minus of a square. So again, by using case number 2, we have to replace d square by minus of a square. So ये जो d square यहाँ पे लिखा है, in place of d square, we have to put minus a square, and value of a it is again m. So minus a square का value हो जाएगा minus m square. So pi it will become x into 1 upon 4 times minus m square and into d operating on sin mx, it is as it is. After that, now 1 upon 4 times minus m square. So we can simplify it. It is a constant term. So इसे अभी बाहर ले लो. pi it is equal to now minus x upon 4 m square, and into remaining operator is only 1 upon d operating on the function sin mx. Okay. Remaining operator is only now 1 upon d operating on the function sin mx. अभी जब तक ऑपरेटर रिमूव नहीं होगा तब तक हमें कंटिन्यूअसली इसे सॉल्व करना है. एंड नाउ वी नो दैट कि if you want to apply case number 2, then we need d square. बट अभी यहाँ पे d square का टर्म तो नहीं है. We are having only d. So अगर इसे d square में कन्वर्ट करना है तो for that we can multiply it by d and divide it by d. Means ऐसे लिख सकते हैं 1 upon d into d upon d, which will become d upon d square. तो डिनोमिनेटर में d square आ जाएगा, उसे हम रिप्लेस कर सकते हैं माइनस a square से, या फिर सिंपली ये 1 upon d जो है डायरेक्टली हम इसे सोल्व कर सकते हैं. वी नो दैट d मींस डेरिवेटिव. ये हमें पता है कि d इट इज डेरिवेटिव विद रिस्पेक्ट टू x, एंड 1 upon d इट इज अपोजिट ऑफ डेरिवेटिव मींस इंटीग्रेशन विद रिस्पेक्ट टू x. सो अभी ये जो ऑपरेटर यहाँ पे 1 upon d लिखा है, इसे हम इंटीग्रेशन में कन्वर्ट कर सकते हैं. मींस इट विल बिकम minus x upon 4 m square into integration of the function sin mx with respect to x. Now we have to take integration of sin mx. अब ये sin mx का इंटीग्रेशन हो जाएगा minus cos mx and upon coefficient of x which is m. Sin का इंटीग्रेशन minus cos and upon coefficient of x. Coefficient of x is here m. So अभी ऑपरेटर d जो है वो completely इक्वेशन से रिमूव हो गया. It means that we got the CF, we got the PI, but just we have to simplify it. And simplification will be minus minus, it will become plus, and m square into m, it will become m cube. So finally PI it is equal to x upon 4 m cube into cos mx. So this is the value of PI. Therefore required solution is CS equal to CF plus PI. So CS equal to C1 cos mx plus C2 sin mx plus C3 e to the power mx plus C4 e to the power minus mx. So first up to here it is the value of CF. and plus value of pi. So pi it is plus x upon 4m cube into cos mx. So which is the required solution of given differential equation. After that, next problem. We have to solve d cube plus 1 operating on y equal to sine 3x minus cos square of x by 2. So as usual, we will write the given differential equation. Now its complete solution is given by Cs equal to Cf plus Pi. So first part, we will find Cf complementary function. And for finding Cf, we need auxiliary equation. So its auxiliary equation is given by f of d equal to 0. And value of f of d in this equation, it is d cube plus 1. So it will become d cube plus 1 equal to 0. Now it's a cubic equation in terms of d. So cubic equation के total 3 roots आना चाहिए, 3 values आना चाहिए. So we can solve it by using calci, but before that we have to write it in the standard format. So we can write it as d cube plus 0d square plus 0d plus 1 equal to 0. And now by using calci, values of d or roots of this equation will be d equal to 1 by 2 plus root 3 by 2 I. It is the first root. 1 by 2 minus root 3 by 2 I. It is the second root. And minus 1, it is the third root. Now, first and second, these two roots contain imaginary term. And again, it is in the form of a pair. So we can combinedly write it as 1 by 2 plus minus I root 3 by 2. And consider it as alpha plus minus I beta. So therefore, roots contain a complex pair. So CF, it will become. For complex pair, formula is e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. After that, ये हो गया 2 roots के लिए, but third root it is minus 1. It is real. So इसके लिए एक और term add करना है plus c3 into e to the power minus x. Now we need values of alpha and beta. So here alpha is the real part and its value is 1 by 2. And beta is the imaginary part and its value is root 3 by 2. So substituting values of alpha and beta. If we substitute here alpha equal to 1 by 2, so it will become e to the power x by 2. And substitute here value of beta. Again here value of beta. So we will get CF equal to e to the power x by 2 in bracket c1 cos root 3 by 2 x plus c2 sin root 3 by 2 x. So ये हो गया CF. First part यहाँ पे. अच्छा, third term as it is plus c3 into e to the power minus x. So first part is completed here. We got the CF. Now we need PI. So formula for PI, it is equal to 1 upon f of d operating on capital F of x. So again, we need here value of operator f of d and value of function capital F of x. So let's check what are the values here. So operator f of d का value यहाँ पे है d cube plus 1 and function it is sin 3x minus cos square x by 2. It is the function. So substituting their values one by one. So ये हो गया operator का value d cube plus 1 and function का value in bracket sin 3x minus cos square of x by 2. Now clearly we can see that function it contains two separate terms separated by this minus sign. So first we will apply the operator on first term separately, then we will apply the operator on second term separately. So pi will become 1 upon d cube plus 1 operating on sin 3x minus 1 upon d cube plus 1 operating on cos square of x by 2. Now in first term, we don't have any issue at all. Function is sin 3x. Power of sin function is 1 and it is free from any type of multiplication. So we can use here case number 2. But in second term, here power of cos function it is 2. और जब तक cos function का power 1 नहीं होगा तब तक हम इस पे case number 2 apply नहीं कर सकते. It means that हमें यहाँ से power 2 को remove करना है. And for that, we can use this formula. We know that cos square theta it is equal to 1 plus cos 2 theta upon 2. 1 plus cos 2 theta upon 2. By using this result, we can simplify the second term. So first term तो मैंने as it is लिख दिया, इसमें कुछ भी change करना नहीं है. Second term we are simplifying here. So cos square theta. So theta is here x by 2. So 1 plus cos 2 theta will become 1 plus cos 2 into x by 2 and upon 2 it is as it is. Operator as it is है 1 upon d cube plus 1. ब्रैकेट के अंदर हम चेंज कर रहे हैं cos स्क्वायर थीटा की जगह पे 1 plus cos 2 theta upon 2. So this is nothing but the value of theta here. Now cos 2x by 2. So 2 and 2 will be get cancel here. Remaining term will be 1 plus cos x upon 2 only. 2 कैंसिल हो जाएगा, रिमेनिंग इज 1 प्लस cos x अपॉन 2. अगेन फर्स्ट टर्म में हमने कुछ चेंज नहीं किया है. Now 1 plus cos x upon 2. Again, we are having in this bracket, we are having two separate terms separated by this plus sign. So first term will be 1 by 2 and second term will be plus 1 by 2 cos x. तो दोनों पे सेपरेटली हमें ऑपरेटर को अप्लाई करना है. तो ऑपरेटर पहले आएगा एंड ब्रैकेट के बाहर यहाँ पे माइनस है, तो बोथ टर्म्स विल बी नेगेटिव. सो फर्स्ट टर्म एज इट इज विदाउट एनी चेंज. सेकंड टर्म विल बी -1 upon d cube plus 1 operating on 1 by 2 and third term will be -1 upon d cube plus 1 operating on 1 by 2 cos x. Now, now focus on the first term and third term. In first term, we are having separate sine function and its power is 1. In last term, we are having separate cos function, again its power is 1. It means that we can apply here second case for finding pi. So for if you want to apply second case, then we need d square. हमें d square चाहिए. तो d square यहाँ पे है नहीं. We are having d cube. So in second and third term, converting operator in the form of d square. d cube को d square के format में convert करना है. तो simply we can write it as d square into d. Again here we can write it as d square into d. तो second and third term, converting operator in the form of d square. अब बाकी है first middle term, second term. तो इन सेकंड टर्म वी आर हैविंग ओनली कांस्टेंट टर्म 1 by 2. और कांस्टेंट को अगर सॉल्व करना है पीआई में, तो मैंने आपको लास्ट लेक्चर में भी बोला है, इफ यू वांट टू सॉल्व कांस्टेंट देन वी कैन राइट इट एज e to the power 0x, we can write it as cos 0x, we can write it as x to the power 0. So always we will take the exponential term because it is easy to solve other as compared to other methods. So second term के अंदर हमें कांस्टेंट को e to the power 0x के फॉर्मेट में लिखना है. ठीक है. तो फर्स्ट और थर्ड टर्म में डी क्यूब को डी स्क्वायर इंटू डी और सेकंड टर्म के अंदर राइटिंग कांस्टेंट एज e to the power 0x. सो pi will become 1 upon d square into d plus 1 as it is into sin 3x as it is. सेकंड टर्म -1 upon d cube plus 1 1 by 2 e to the power 0x. सिर्फ 1 by 2 था, e to the power 0x हमने यहाँ पे एक्स्ट्रा का ऐड कर दिया. थर्ड टर्म -1 upon d square into d. तो फिर से ये d cube को d square into d यहाँ पे लिखा है plus 1 as it is and 1 by 2 cos x as it is. Now in first term, replacing d square by minus of a square. So what is value of a in the first term? A, it is coefficient of x in the angle of trigonometric function. So here value of a, it is 3. So minus a square का value हो जाएगा -9. After that, in second term, replacing, in second term we are having exponential function. And exponential function को case number 1 से solve कर सकते हैं. And for applying case number 1, we have to replace d by a. So in second term, replacing d by a and value of a is here 0. e to the power 0x है, coefficient of x is 0. So value of a is here 0. After that, in third term, by using case number 2, again replacing d square by minus of a square. And what is value of a in the third term? So in third term, coefficient of x is 1. Cos x. Angle में यहाँ पे x का coefficient 1 है, तो a का value 1 हो जाएगा. a का value 1 हो जाएगा. It means that minus a square will become -1. So applying these changes one by one term wise, pi will become 1 upon d square. तो d square की जगह पे -9 पुट करना है, तो ये हो गया -9d. d square into d है, तो d square is -9 into d as it is plus 1 as it is, operating on function as it is. Next term -1 upon, we have to replace d by 0 in second term. तो d cube की जगह पे ये 0 आ गया plus 1 as it is and function as it is. In third term, again replacing d square by -1. So d square into d, it will become -1d plus 1 as it is and function as it is. Okay. Now, term wise फिर से focus करना है. What is remaining now? So if you focus on the first term, so in first term we are having -9d plus 1. तो पहले नेगेटिव टर्म, उसके बाद पॉजिटिव टर्म, समथिंग इट इज फीलिंग लाइक ऑड थिंग. पहले हम पॉजिटिव लिखेंगे, उसके बाद नेगेटिव. वी कैन रीअरेंज द टर्म्स एंड वी विल राइट इट एज 1 upon 1 -9d ऑपरेटिंग ऑन sin thrice x as it is. सेकंड टर्म के अंदर से ऑपरेटर d जो है वो रिमूव हो गया, मींस सेकंड टर्म हमारा सॉल्व हो गया. तो 1 upon 1 इट विल बी 1. रिमेनिंग टर्म फंक्शन एज इट इज minus of 1 by 2 e to the power 0x. यहाँ से d रिमूव हो गया, मींस ये सेकंड टर्म हमारा सॉल्व हो गया. थर्ड टर्म इट इज माइनस डी प्लस वन। तो अगेन पहले नेगेटिव फिर पॉजिटिव, उसकी बजाय पहले पॉजिटिव लिखना है फिर नेगेटिव लिखना है। सो थर्ड टर्म विल बिकम 1/1 माइनस डी ऑपरेटिंग ऑन 1/2 cos x as it is. Okay. So out of these three terms on right hand side, only second term is solved. सेकंड टर्म में ऑपरेटर डी नहीं है, ऑपरेटर डी रिमूव हो गया, मींस ये टर्म हमारा सॉल्व हो गया। बट फर्स्ट टर्म एंड थर्ड टर्म कंटेन ऑपरेटर डी। यहाँ पे 1 माइनस 9d लिखा है, यहाँ पे 1 माइनस d लिखा है। दीज टू टर्म्स कंटेन d, और जब तक ऑपरेटर d रिमूव नहीं होगा तब तक कंटिन्यूअसली हमें इसे सॉल्व करना है। बट अभी सॉल्व करना है तो उसके लिए फंक्शन अगर चेक किया तो फंक्शन इज साइन एंड हियर फंक्शन इज कॉस, मींस वी हैव टू अप्लाई केस नंबर 2। और केस 2 अगर अप्लाई करना है तो फॉर दैट वी हैव टू रिप्लेस डी स्क्वायर बाय माइनस ऑफ ए स्क्वायर, और डी स्क्वायर का टर्म तो यहाँ पे है ही नहीं। वी आर हैविंग 1 माइनस 9d एंड हियर वी आर हैविंग 1 माइनस d। तो डी स्क्वायर का टर्म अगर नहीं है तो हमें डी स्क्वायर में इसे कन्वर्ट करना होगा, बिकॉज द ओनली वे टू गेट द सॉल्यूशन इज रिप्लेस डी स्क्वायर बाय माइनस ऑफ ए स्क्वायर। केस नंबर 2 अप्लाई करना है तो हमें डी स्क्वायर को ही रिप्लेस करना है। अभी यहाँ पे डी स्क्वायर का टर्म नहीं है तो फिर हमें डी स्क्वायर का टर्म क्रिएट करना होगा। वी हैव टू कन्वर्ट दिस ऑपरेटर इन द फॉर्म ऑफ डी स्क्वायर। जो 1 माइनस 9d लिखा है इससे डी स्क्वायर के फॉर्मेट में कन्वर्ट करना होगा। 1 माइनस d लिखा है इसे भी डी स्क्वायर के फॉर्मेट में कन्वर्ट करना होगा। एंड हाउ वी विल कन्वर्ट इट इन द फॉर्म ऑफ डी स्क्वायर, फॉर दैट अभी क्या करना है, लेट्स चेक इट कि अभी इसे डी स्क्वायर के फॉर्मेट में कैसे कन्वर्ट करेंगे। सो इन फर्स्ट एंड थर्ड टर्म कन्वर्टिंग ऑपरेटर इन द फॉर्म ऑफ डी स्क्वायर, सेम थिंग जो मैंने आपको बोला है। अब इसे कन्वर्ट कैसे करना है, सो फॉर दैट वी हैव टू मल्टीप्लाई एंड डिवाइड ऑपरेटर्स बाय देयर कॉन्जुगेट्स। वी हैव टू मल्टीप्लाई एंड डिवाइड ऑपरेटर्स बाय देयर कॉन्जुगेट्स। अभी कॉन्जुगेट मींस दिस ऑपरेटर इट इज 1 माइनस 9d, तो इसका कॉन्जुगेट होगा 1 प्लस 9d। दिस ऑपरेटर इट इज 1 माइनस d, तो इसका कॉन्जुगेट होता है 1 प्लस d। मींस साइन को आपको चेंज करना है एंड यू विल गेट द कॉन्जुगेट। सो मल्टीप्लाइंग एंड डिवाइडिंग ऑपरेटर्स बाय देयर कॉन्जुगेट्स, मल्टीप्लाई भी करना है और डिवाइड भी करना है, ठीक है। सो पी आई विल बिकम 1/1 माइनस 9d। जो ऑपरेटर था पहले इसे एज इट इज लिखना है, इसके बाद इसका कॉन्जुगेट से मल्टीप्लाई करना है और डिवाइड करना है, तो ये होगा 1 प्लस 9d अपॉन 1 प्लस 9 ऑपरेटिंग ऑन फंक्शन एज इट इज। सेकंड टर्म के अंदर e to the power 0x एक्सपोनेंशियल टर्म इट इज 1, सो रिमूव इट। वी हैव इंट्रोड्यूस्ड दिस टर्म टू गेट दिस सॉल्यूशन। अभी ये सॉल्व हो गया, मींस एक्सपोनेंशियल टर्म को रिमूव कर सकते हैं, तो -1/2 एज इट इज। लास्ट टर्म 1/1 माइनस d, इट इज द ओरिजिनल ऑपरेटर, और यहाँ पे 1 प्लस d और 1 प्लस d से मल्टीप्लाई किया और डिवाइड किया, ठीक है। आफ्टर दैट फंक्शन इट इज एज इट इज। अभी कॉन्जुगेट से मल्टीप्लाई और डिवाइड करने से हमें क्या आएगा, लेट्स चेक इट। लेट्स फोकस ऑन द डिनोमिनेटर। numerator it is 1 plus 9d, here numerator it is 1 plus d, but denominator को अगर चेक किया, so here in denominator we are having 1 minus 9d into 1 plus 9d, 1 minus 9d into 1 plus 9d, it is in the form of a minus b into a plus b, and a minus b into a plus b, it is nothing but expansion of a square minus b square, means हमें स्क्वायर के फॉर्मेट में टर्म आ जाएगा जो हमें चाहिए था। हमें डी स्क्वायर के फॉर्मेट में टर्म चाहिए, तो 1 minus 9d into 1 plus 9d, it is in the form of a minus b into a plus b, तो ये हो जाएगा a square minus b square, means 1 square minus 9d bracket square. Similarly, here 1 minus d into 1 plus d, again it is in the form of a minus b into a plus b, so we can write it as a square minus b square, तो यहाँ पे हो जाएगा 1 square minus d square. So it will become now numerator as it is 1 plus 9d, and denominator it is a square minus b square, operating on function as it is. Second term minus 1/2 as it is. Third term minus 1 plus d, numerator as it is, denominator में आ गया a square minus b square, operating on function it is as it is. So in this way we got the term of d square. हमने d square का term यहाँ पे इस तरह से लेकर आ गए. After getting d square, now in first term replacing d square by minus of a square, and which is equal to minus 9. In first term replacing d square by minus a square. अभी इसे पहले simplify कर सकते हैं. Simplification means we can write it as here 1 square means it will be 1 and minus 9d whole square. तो ये हो जाएगा 1 minus 81d square. 9 का square 81 and into d square. Second term minus 1/2 as it is. Third term it will become minus of numerator as it is and 1 square minus d square means it is only 1 minus d square. तो ये होगा simplified format. And after getting the simplified format, now in first term replacing d square by minus of a square. So value of a it is again 3, coefficient of x, तो a square का value हो जाएगा 9. So minus a square की जगह पे हमें minus d square की जगह पे minus 9 पुट करना है. And in third term replacing d square by minus a square, value of a is here 1, x का कोएफिशिएंट यहाँ पे 1 है, तो minus a square का वैल्यू हो जाएगा -1. तो substituting these values, pi will become 1 plus 9d upon 1 minus 81 into -9. d square की जगह पे आ गया -9. Function as it is. Second term minus 1 by 2 as it is. Third term minus 1 plus d upon 1 minus d square. तो अब ये d square की जगह पे आ गया -1. And function 1 by 2 cos x as it is. Now simplified. So multiply this. Minus minus it will become plus, and 81 into 9 it will become 729. Again function as it is. Second term as it is. Third term का numerator as it is रखना है, and 1 and minus minus it will become +1. ठीक है? Again function as it is. Now 1 plus 729. So 1 upon 730 it is constant. तो उसे हम operator के अभी बाहर लिख सकते हैं. Remaining operator is now in the numerator 1 plus 9d. That is the remaining operator. Function as it is, minus 1 by 2 as it is. Now here 1 plus 1 it will become 2, so 1 by 2 is constant. फिर से इसे ऑपरेटर के बाहर ले सकते हैं, minus 1 by 2, and remaining operator it is 1 plus d, and function as it is. So अभी डिनोमिनेटर से तो ऑपरेटर सॉल्व हो गया, बट वी आर हैविंग ऑपरेटर इन न्यूमरेटर नाउ, और न्यूमरेटर में अगर ऑपरेटर आता है तो इट मींस दैट इट इज नथिंग बट डेरिवेटिव. अभी इसे सिंपली सॉल्व करना है. अब इसके लिए कोई आपको डिफरेंट केस अप्लाई करना नहीं है. अब ये sin 3x को ब्रैकेट के अंदर मल्टीप्लाई कर दो. फर्स्ट टर्म विल बिकम 1 into sin 3x, इट इज sin 3x, एंड सेकंड टर्म विल बिकम 9 times d of sin 3x. ठीक है? सिमिलरली ये 1 by 2 cos x को ब्रैकेट के अंदर मल्टीप्लाई करना है, तो ये 1 by 2 into 1 by 2 वी कैन राइट इट एट 1 by 4. 1 by 4 ऑपरेटिंग ऑन 1 plus d into cos x. तो यहाँ पे मैंने लिख दिया 1 by 4 1 plus d ऑपरेटिंग ऑन cos x. नाउ अभी पहले ये हो जाएगा 1 into sin 3x, इट इज sin 3x, और उसके बाद नेक्स्ट टर्म आएगा 9 times d of sin 3x. तो ये हो गया sin 3x फर्स्ट टर्म एंड 9 times d of sin 3x सेकंड टर्म. उसके बाद -1 by 2 as it is, -1 by 4, 1 into cos x पहले आएगा cos x, आफ्टर दैट प्लस d of cos x will be the second term. तो ये हो गया cos x and plus d of cos x. Now what is d of sin 3x and what is d of cos x? So we know that d means derivative, d by dx. तो इसका मीनिंग ये होगा कि we have to take derivative of this bracket, we have to take derivative of this bracket with respect to x. तो अभी पहले sin 3x का डेरिवेटिव with respect to x, sin 3x का डेरिवेटिव होगा cos 3x into 3. तो ये आ गया ब्रैकेट के अंदर 3 times cos 3x. d रिमूव गया, we have taken the derivative, तो अभी d रिमूव हो जाएगा. sin 3x का डेरिवेटिव 3 times cos 3x. Similarly, -1 by 2 as it is, and last term -1 by 4 cos x as it is. Derivative of cos x it is minus sin x. तो d रिमूव हो जाएगा, we have taken the derivative, तो ये cos x का डेरिवेटिव आ जाएगा minus sin x. Now in this way अभी complete equation से operator d जो है वो रिमूव हो गया. It means that we got the solution. अभी सिर्फ simplified format में इसे लिखना है. So pi will become 1 upon 730 in bracket sin 3x plus 9 3s are 27 cos 3x, minus 1 by 2 as it is, minus 1 by 4 as it is, in bracket cos x, and plus into minus it is minus sin x. So this is the final pi for the given differential equation. And finally, therefore required solution is given by cs equal to cf plus pi. Substituting value of cf and value of pi. So cs equal to कॉम्प्लीमेंट्री फंक्शन CF जो हमने कैलकुलेट किया था पहले उसका वैल्यू पुट करना है, तो ये हो गया CF का वैल्यू. इसके बाद PI का वैल्यू पुट करना है, तो ये होगा PI 1 upon 730 in bracket sin 3x plus 27 cos 3x minus 1 by 2 minus 1 by 4 cos x minus sin x, and it is the required solution of given differential equation. Okay. So in this way we can solve the problems having function sin x or cos x based on case number 2. So with that we will stop here. In next lecture we will take third case for finding pi if the function is algebraic x to the power m. So thank you very much.